So in our previous video, we looked at the possible dimensions that could be used to form a right triangle. But today we'll be looking at finding missing sides of a right triangle by using Pythagorean theorem. Pythagorean theorem. We actually looked at this. Which the formula is a squared plus b squared is equal to c squared. And if we remember, we remember that the longest side is c, and we could just place b and a like anywhere right there in the triangle. So we're gonna simply use this theorem to solve for missing sides of a right triangle. Now, bear in mind, we have three sides, and two will always be known, but one will always be missing. So any one of the sides could be missing at any time. Any one of the sides. And so we're going to do both. We're going to do when C is missing, or this side is missing, or this side is missing, and also to see if we can do a worded real life problem. And that would be it for this video. So let's go. Now, if I have a triangle like this, and I say, I'm going to label this as, I'm going to say, this is 6, this is 8. And I want to find x. Let's call the side x. All right, I could label my triangle as A, B, C if I want. And I want to find the value of x. Now we could do this, we could represent this equation in two ways. We could actually represent this equation. Well, this is the general equation. A squared plus B squared is equal to C squared. But in light of these dimensions, A to B, B to C, C to D, we could actually represent this two ways if we want. We could say, okay, we need to form a triangle. We could say, all right, this side squared plus this side squared is equal to this side squared. So we could say AB, let me change my color to blue. I could say AB squared plus, let me see. I'm gonna need some space here. So let's say, let's write this over here. I had 6, I had 8, this was X, this was B, this was A, B, C. So I could say AB all squared plus BC all squared is equal to AC all squared. And all we're going to do is to take these respective values and substitute them into the equation. So we're going to say, so AB is 6 squared. That is 6. I plug that there, I got 6 squared. Plus BC is 8. You square that, and AC is X. We don't know what is that. And so what we're going to do is to simplify this equation. So 6 raised to the second power is 36. 8 raised to the second power is 64. And X raised to the second power is X. All right, let me clear this up. So we have 64 plus 36 is equal to X squared. When we add this, we get 100. Then we want to get rid of this square so we can have the X by itself. And the opposite of square is square root. Whatever we do on one side, we do the same thing on the other side. So this square cancels that square root, and the square root of 100 is 10. Well, we take the positive value of it because a square gives you two solutions. But normally we want to take the positive value of the square root answer. Because when we're dealing with distance, we normally use a positive value. Let's do another one. And let's do one when the Let's do this one when one of the shorter sides are missing. So it's x right there. I'm gonna put down 3 right there. Now all I'm gonna do, if I label this as, if I don't give this any label, if I don't label this triangle, I could just say a squared plus b squared is equal to c squared. All I'm gonna do is to plug my values into this function and in this equation and solve for x. So let us see. Let's be very careful of how we substitute the values. So for A, we could put 4 there. For B, we could put X there. And for the longer side is 5. Now, bear in mind, you don't put X on this side all the time. You put X there if X is right here, because the longer side goes right here. You take the longest side and you plug it on this side. That's where I see many misconceptions with students when they're doing this. They always believe that X should be on this side. No, the X goes anywhere depending on where X is on the triangle. So this one always, whatever you put here, always goes right there. So in this case, X is right here. So X must be somewhere over here and not right there. All right, so let's go. So let's simplify this. Very simple. So 4 squared is 16, x squared is x squared, and the square of 5 is 25. Now all we're going to do is to make x the subject. So we just clear this off right here. And we say 16 plus x squared is equal to 25. Now we want to have this by itself, so we're going to subtract both sides by 16. That cancels that. X squared is equal to 25 minus 16 gives us 9. We find the square root, then x is going to be equal to 3. Very, very simple. Now, this is just the two conditions you might have this equation where you want to find the longer side, what's the value of the longer side, or the value of the shorter side. So this is basically what you would do with the Pythagorean theorem. But we want to try to do a worded problem. So let's see if we can do a word problem. So I'm going to read something while we try to visualize this. So it says 2 joggers, they run 8 miles north. And if you know the north, south, east, west direction, we know that north goes in this direction. That's on a flat surface like that. And then we're gonna say this is 8 miles. Now the other one, no, so the other part of the question says, then they turned they turned 5 miles west. West is this direction. So we move 5 miles. And then it is asking us, what is the shortest distance they must travel to return their starting point? So they started right here. And if we could just close this off like a right triangle right there. And so they would just travel back here, coming back there. So this is the unknown. We don't know. So we need to find that. So once you have a right triangle, Pythagorean theorem. So we say we're gonna write over equation. So we say a squared plus b squared is equal to c squared. And all we do is just plug these values into the formula. So we say, now look at this. The longer side is here. Therefore, the longer side is going to be right here, which is x. So we write 5 squared plus 8 squared is equal to x squared. The square of 5 is 25. The square of 8 is 64. The square of x is just x. You don't know what is that. We're going to find it very soon. All right, so after that, we simplify this part. Put this over here. So we say 25 plus 64 is 89. Is equal to x squared. Now we want to get rid of the x. So we square root both sides. And x will be equal to 9. And there you go. Using Pythagorean theorem to solve for a missing side of a right triangle. And always remember where to substitute your values into the formula so you don't get it mixed up. So there you go. Stay tuned for more video. Please remember to subscribe.